Okay, so so let's start, since the Coulomb's law, it's easy, right? You can name it. Let's start by reading the statement, okay? So they say the small isolated sphere A, okay, with the mass of 0.2 kg, okay? So this sphere has got the mass of 0.2 kg. Sorry, gram, sorry, not kg. 0.2 gram, all right? Carrying a charge of 7 times 10 exponent 9 negative 9 coulomb, which is same as 7 nanocoulomb, right? So yeah, and then it is suspended from a horizontal. Once they say is suspended, that means that this sphere is at the point of rest. Okay, so this tension, it's make the sphere to hang right on that cylinder. Okay, so they say from the
Mm.
horizontal surface by the string of negligible mass. Okay, so we are neglecting the mass of the tension. Okay, a second sphere B carrying a charge of negative 8 times 10 exponent negative 9 coulomb, which is same as negative 8 nanocoulomb, on an isolated state on an isolated stand, attract sphere A so that the string forms an angle of 20 uh, degrees, okay, to a vertical. Okay, so basically what happened is that as this sphere, right, was hanging, right, so sphere A at the beginning was hanging here, right, and then because of the presence of sphere B, which is here, and remember, since these spheres have unlike charges, so what type of force would be between these two charges?
A negative and a positive.
No, what type of force? Is it a force of
Force of
attraction or force
attraction.
of repulsion?
Force of attraction.
Force of attraction. Okay, since the force of attraction, therefore sphere A will move towards sphere B, right, and sphere B will move towards sphere A. That's why you can see that this angle is being formed here. Okay, so the sphere moved, it's swing right like this, and then it's swing to that direction in such a way that it's formed a certain angle here. So the angle that it's formed here is 20 degrees, right? So the sphere was here. For example, the sphere was, I want to draw the straight. The sphere was here, and then it swinged to here, and then it's formed 20 degrees, which is an angle. Do you understand that?
Yes.
Okay, and then the horizontal distance between the centers of the two spheres is 3 centimeters. Okay, and then refer the diagram below. So you are given the diagram, and then you stated the Coulomb's law, which is fine. A force of attraction or repulsion is directly proportional to the product of the charges and inversely proportional to the square of distance between them. Okay, that is the Coulomb's law. All right, and then the next question, which is 9.2, they say draw a vertical diagram of the forces acting on sphere A, right? Indicate at least one angle. Okay, so for you to do this, you have to note all the forces. You have to draw all the forces that are acting on sphere A, and remember that they want you to draw the free body diagram. And remember that they also gave you the, what is this, they gave you the mass of the sphere, right? So the first thing that we will draw the free body diagram. We can draw the dot, right? So the first one will have the tension. Oh, they want the vector diagram, not the free body diagram. They want the vector diagram. Okay, so if they want the vector diagram, we can draw this sphere, which is A. Okay, so the first one, it will be the tension, which would be here. Okay, that is the tension. And since the sphere has got the mass, okay, since the sphere has got the mass, therefore it will have a
Mm.
weight. So the weight is always downward. So we'll call this Fg, which is the weight. Okay, and then here it will be the force that will be exerted by sphere B on A. right? So this force would be that direction. Okay, so this is the force of attraction, so which is the force that is exerted by sphere B on A. Okay, and then they say indicate the angles. So it's either you indicate this angle that is here, so here you'll have 20 degrees, or you can draw the parallel line to this line, which we can draw it here, right? uh, which we can draw it here, and then this line is parallel to that line, so this is the alternating angles. Okay, so this 20 degrees will also be here. Okay, so you can draw this diagram, or we can draw the free body diagram to show this much simple. So if we are drawing the free body diagram, we'll have the tension, which would be like that. So that is the tension. We'll have the weight, which would be like this, which would be downward like this. That is the weight,
Mm-hmm.
which is Fg. And we'll have the force that is exerted, which is F, the force that is exerted by sphere B on A. Okay. Okay, sorry about the. Okay. What happened now? Okay, there you go. I wanted to. I want you to expand this. Okay, there you go. Okay, now if I'm drawing this, the free body diagram, and then I can draw this because they say I represent at least one angle. Obviously, I have 20 degrees here. Oh, why this line is not. Okay, so I can draw the line that is parallel to this line. If I'm drawing here, so that is 20 degrees here, and then if I'm applying the Z shape, right, Z shape, this angle is equal to that angle. So alternating angles, I will also have 20 degrees here, right? So do you have any question here?
No question, Sipa.
Okay, so this is the vector diagram that they are looking for. So this is how you're going to draw it. Okay, then the next question, they say calculate the magnitude of the electrostatic force that sphere B exerts on sphere A, which is the force that you calculated very well. There's nothing wrong that, on what you did. Everything is fine. So you use F equal to K Q1 times Q2. Let me just use A and B because I have the alphabet. So the force that is exerted by sphere B on A is K QA, right, times QB over RAB. So the angle, the distance between A and B squared. Okay, and then we can plug in the values. We have 9 times 10 exponent 9, and then QA. And remember, I said you'll not include the signs. You'll always include the positive sign, and keep in mind that since we have unlike charges, we have the force of attraction. So here QA is 7 times 10 exponent negative 9, and then the last one is 8 times 10 exponent negative 9. Divide that by all of it. Divide that by 3 times 10 exponent negative 2 squared, because you have to convert that. Did you convert this to meters? Because they gave you centimeters. Did you convert that to meters?
Yes, Sipa.
Okay. Then what is the answer that you got?
For for that one I got 5.60 times 10 negative 4 attract.
Some 10 exponent negative 4. Oh, A second mistake that I noticed, you didn't write the unit. So remember that the unit is Newton, right? Be careful.
Newton. Yes.
Newton. Then it's 5.6 times 10 exponent negative 4 Newton, right? And then this is the force of attraction, as you said, because we have unlike charges. So you write attraction here. That is fine. Okay. Now, 9.4. How do you answer 9.4? So to answer 9.4, it's very simple, right? Since this sphere A is only moving horizontal, okay? Sphere A is only allowed to move horizontal. But at this point where it's formed the angle like this, the horizontal component, right, will be 0. Okay, let me put it this way. Since the sphere A is only moving horizontal, is not moving vertical, that means sphere A is only accelerating horizontal and is not accelerating vertical. And remember, if the acceleration is 0, that means that the net force would be 0, because remember, the net force is equal to ma. Okay, since the sphere A is not accelerating upwards, right? So that means the acceleration would be 0. If I'm plugging 0 here, I will have am equal to 0. Then I'll have the net force being 0. So that simply means that the net force, right, or all the forces that are acting vertical on sphere A, they are added up to 0, right? So the net force for that is 0. Do you have any question here?
No question, Sipa.
So what we have to understand is this. This tension, since this tension is acting at an angle, you have to break it into component. This tension has got the vertical component, which we can call it Ty, and the horizontal component, which we can call it Tx, right? So
Yes.
if I'm adding Ty, which I will take upwards as positive, okay? I'll take upwards as positive and I'll take downwards as negative. If I'm adding Ty, I'm saying Ty, okay, plus, right? And then I will take downwards as negative, which is Fg. Fg is the weight, and then which would be minus Fg. Minus Fg. This would give me 0. This would be added up to 0. Okay? And remember, Ty minus Fg is the same as the weight. The weight is, if you want to calculate the weight, is the mass times the gravitational acceleration, which is mg equal to 0. Do you have any question here?
No question, Sipa.
Okay. Now, the next step, okay. Okay. Do you still can see where I'm writing?
Yes, Sipa.
Okay. Now, we have Ty, we have mg. Okay. Now, we have to find, what is this? We have to find Ty. So, Ty is the horizontal component of this tension. So, I can also draw the line that is parallel to Tx. So, I can draw it here. So, if I'm drawing the line that is parallel to Tx, that means Tx will be here. So, I'll have Tx here, right? So I'll have Ty and have Tx, and then I have 90 here. So the right angle triangle, it's formed like this. So the hypotenuse is T, right? The adjacent side to this angle of 20 degrees here is Ty, while the opposite side of this angle 20 degrees is Tx. But I'm interested to find Ty. So since I'm interested to find Ty, I have the adjacent and the hypotenuse, so I can use cos 20. So remember, cos 20 on this angle, right? It's adjacent side, which is Ty, over hypotenuse, which is T. So this is equal to the adjacent side, which is Ty, over T. So I want to make Ty be the subject of the formula, so I can cross multiply this. So Ty will be equal to T times cos 20. Do you have any question here?
No question, Sipa.
Okay, So at this point, I can just plug in the values. So Ty is T 20 is T cos 20 minus, and then now I'm gonna plug in the mass of the sphere A. It was given to be 0.2 gram. Now I have to convert that gram into kg. Remember, 1 kg is equivalent to 1000 gram, right? So if I want to
Yes.
find kg, I have to divide that by 1000. So I will have 0.2 times 10. Okay, let me just try to make this quite small. Okay, so I would have 0.2, right, times 10 exponent negative 3 times 9.8 equal to 0. So if I'm saying 0.2 times 10 exponent negative 3, I'm simply means that I'm dividing that by 1000, right? In the simplest form, I can
Yes.
just say 0.2 divided by 1000. Do you understand?
Yes, Sipa.
So now we can have t cos 20 minus, what is 0.2 times 10 exponent negative 3 times 9.8?
Let me check that. It's 1.96
Is
times 10 negative 3.
is 1.96 times 10 exponent
Negative 3.
negative 3 equal to 0. Okay, now we can take this to the side. So t cos 20 equal to 1.96 times 10 exponent negative 3, because we want the tension, so we can divide by cos 20 on both sides. Okay, divide by cos 20.
Yes.
So therefore t, which is the tension, will be equal to 1.96 times 10 exponent negative 3, okay, divide by cos 20. So can you quickly punch the calculator and then give me the final answer?
Okay. It's 2.09
That's it.
times 10 negative 3.
Times 10 exponent negative 3 Newton. Right? So this is how
Yeah.
you calculate the tension, right, of this question. Do you have any question here?
No question, Sipa.
All right.